ICSE warriors. How are you guys? Welcome back to my channel. My name is PrachiSharma and welcome back to a series of mind mapping. On popular request, today's topic that we are covering is hydrogen chloride. Mind mapping is a consolidated way of revising a particular chapter on a fast track. So, without wasting any time, let's get started with hydrogen chloride mind map. So students, let's get started with today's session. I hope my screen is clearly visible to you. These notes are available in the description box. Also, they are uploaded on the Telegram channel. So if some of you were facing issues with the description box link, it is working now. But still, if you would like to get frequent updates on the Telegram, you can join that, and all the notes are directly posted there, so you can automatically receive them. Now, let's get started with hydrogen chloride. So how these notes are working? I have hydrogen chloride one gas on one page, and I have hydrogen chloride acid, hydrochloric acid on the next page. So we'll work on one page at a time. And after that, I don't have any diagrams in this one. I have mentioned them right here. So let's get started with HCl gas, that is hydrogen chloride gas. We'll start with the lab preparation. So lab preparation I have divided into A, B parts and C part. So let's get started with it. So for lab preparation, you have NaCl reacting with H2SO4 at a temperature lower than 200 degrees Celsius, which will give you NaHSO4 plus HCl gas is liberated. Now it's important that you maintain the temperature at lower than 200 degrees Celsius, because if you go higher than that, in that case, first of all, you're wasting the fuel. Second, your sodium sulfate is formed, which is very sticky material. It will stick to the beaker and it will be very hard to clean, and that may also cause damaging the entire apparatus. So it is important that you maintain the temperature lower than 200 degrees Celsius. Although when you have above 200 degrees Celsius, you have more HCl gas coming out, but that is not efficient for us because it is causing more damage than giving us HCl. So that is the reason it is important that we maintain the temperature lower than 200 degrees Celsius. So let's look at that. So first equation is when the temperature is lower than that. Second equation is when the temperature is above 200 degrees Celsius. So you have NaCl plus H2SO4 at higher than 200 degrees Celsius, Na2SO4 plus HCl gas. Now why do we prefer NaCl? We prefer NaCl because it is cheap and it is easily available. So NaCl is cheap, therefore preferred for this preparation over other metal chlorides. Then second is, why is concentrated nitric acid not used for this preparation? Why are we using H2SO4? The reason is that nitric acid is very volatile in nature. So when HCl vapors will start coming out, along with that nitric acid vapors will come out, and therefore the product won't be pure. So that is the reason we don't use nitric acid, we use H2SO4 because H2SO4 is a non-volatile acid. Let's move to the second portion, the collection of this gas. So these type of questions can be asked. They can ask you why nitric acid is not used, why do we prefer NaCl, how is the gas collected. So collection is by the upward displacement of air. Why is that? Because HCl gas is heavier than air, so it will automatically sink into the beaker and it will push out air. Then the second is, it is not collected over water because it is highly soluble in water. So you have two reasons there. And how is it collected? It is collected by upward displacement of air. Let's move to the next one. Now this can be asked. For example, they give you the apparatus, they ask you these couple of questions, and then they will say predict the products. So when you predict the products, you'll say okay, HCl gas is coming out. The next question can be, how will you confirm your answer? So for that you need to know the identification of the gas. So how will you identify? You can say when the jar is completely filled with HCl gas, white fumes appear on the top. That is first identification. The second can be, a glass rod dipped in ammonium hydroxide is brought near the beaker and you see dense white fumes of NH4Cl come out. So that is another identification. You can say identification or test of HCl. So these two are important for you to learn. Now the next part of the same lab preparation is the precautions. So the first precaution is lower end of the thistle funnel must be dipped in concentrated H2SO4. So there is a long thistle funnel. After this lab preparation understanding, we'll come on the diagram. So the lower end of the thistle funnel should be dipped in H2SO4 directly. The second precaution is delivery tube should be dipped in drying agent. So the drying agent in the second portion, and your delivery tube in which the HCl gas is going out, it should be dipped in the drying agent. What is the drying agent? It is concentrated H2SO4. Now temperature is maintained nearly 200 degrees Celsius. That is the third precaution. Now what happens if the temperature is above 200 degrees Celsius? So apparatus made of glass may crack. Second, wastage of fuel. Third, sodium sulfate formed a sticky, hard crust which may spoil the apparatus. Make sense? Let's move to the E part. So you have the apparatus right here. If you see, this is the thistle funnel that they are talking about. This thistle funnel should be dipped in H2SO4. Then the next is, this is the delivery tube which is carrying your HCl gas. And this is your drying agent, concentrated H2SO4. So the delivery tube should be dipped in concentrated H2SO4 right here. So this is your next understanding of the apparatus. Then after drying, the gas is collected in the jar right here by upward displacement of air. Okay, let's move to the next part. This is an experiment to demonstrate the density of HCl gas, that it is heavier than air, it is denser. So what we are doing, we have a beaker, we have a jar which is open from the top, you have a candle burning, and from a side you tilt in a beaker with HCl gas in it. So HCl gas goes in and slowly displaces air out. So it throws out air and takes up all the space in the jar. Eventually the candle that was being lit will get extinguished, it won't be lit anymore. So this experiment tells us that HCl gas is heavier than air. So let's read it. It can be proved by pouring the gas in a jar with a burning candle. The candle gets extinguished because HCl gas, being heavier, occupies the lower portion of the jar and forces the air out. This experiment also proves that HCl gas is neither combustible nor a supporter of combustion. Extremely simple experiment, but it can come in the exams. Okay, let's move to the next one. This is an experiment to demonstrate solubility. So we mentioned that HCl gas is highly soluble in water, and this is an experiment to prove it. The name of this experiment is fountain experiment, and this is what the apparatus looks like. Why is it called fountain? Because you see a fountain in the round bottomed flask on the top. So let's read about it. As the water goes in the flask from the dropper, HCl gas present in the flask dissolves due to its high solubility, thereby lowering the pressure inside. The outside pressure being higher pushes the blue litmus solution inside through the jet tube. The blue litmus solution turns red due to the acidic nature of HCl gas. Now let's look at the apparatus and understand what are we talking about. So when you look here, let me use a different color. When we see here, this is a dropper right here. So as soon as you press the dropper, water droplets enter right here into the round bottomed flask. As water enters, the HCl gas which is present in the round bottomed flask will get dissolved in water, creating a vacuum there. And as vacuum is created, to occupy that space, blue litmus solution rushes up and it is blue in color. As soon as it reaches up and there is left out HCl gas in the jar, it turns it red because of its acidic nature. So you get a beautiful red fountain in the round bottomed flask. This is the fountain experiment. Okay, let's move to the next one. This is reaction with ammonia. So HCl reaction with ammonia. So HCl combines with ammonia to form dense white fumes of ammonium chloride. NH3 plus HCl gives NH4Cl. This is also an important answer for a question when two colorless gases combine to give you a solid or a colored solid. So ammonia plus HCl gives you NH4Cl. So this was it for your HCl gas. You can take a screenshot, or you can take notes, or you can download this entire file from the description box or the Telegram channel. Now let's move to the next part. This is HCl acid. HCl acid or hydrochloric acid is also known as muriatic acid. When HCl gas is combined with water, you get H3O positive ions and Cl minus ions. That means your hydrogen chloride gas ionizes on mixing with water, giving you an acid, that is hydrochloric acid. Now let's start with the basic understanding, that is lab preparation. Now the entire lab preparation for HCl gas is the same here. It is just that when you get, where is the apparatus? Right here. So when you start getting your HCl gas over here, you dissolve it in water. Instead of collecting it into a jar, you dissolve this into water. So this entire preparation becomes for hydrochloric acid. So let's look at that. Now, how does the mechanism work for dissolving HCl gas into water? So this is the apparatus for it, if you can see. So you have an inverted funnel arrangement. Why do we use inverted funnel arrangement? That's an important question, because if you are using a tube, let's say this is the tube and you have water here. So what would happen is, the speed with which HCl gas dissolves in water is comparatively very high than the preparation of it. So the HCl gas that is coming in has a very slow speed compared to how fast it dissolves in water. So what would happen, as the HCl gas that comes into the funnel, water dissolves it and it creates a vacuum. So water gets sucked up into the tube and it keeps dissolving the HCl gas in the entire delivery tube. What will happen at the end? Water will reach in the flask before it, and that may cause an explosion, because you have hot contents before that and your water reaches there. So that is the reason we use round bottomed flask. It increases the surface area for solubility of water in it, and even if water rises up into the funnel has a large surface area, so eventually it will drop the water back in. It won't let back suction happen. Okay, so let's read about the mechanism by which back suction is avoided. Inverted funnel arrangement prevents or minimizes back suction of water. It provides a large surface area for absorption of HCl gas. Now next is why funnel arrangement is used. HCl gas is highly soluble in water, so it is absorbed in water more quickly than it is generated. Therefore, the pressure in the flask and the delivery tube is reduced, and the atmospheric pressure from the outside forces the water back up to the delivery tube. This effect is called back suction. So in this you get an answer for why funnel arrangement is used. Also you get the answer for what is back suction. Okay. Now let's move to the second part. Now, if the tube is made of ordinary narrow glass tubing, which I just mentioned, the water will quickly fill in and pass over into the generating flask. This would stop the reaction and might result in an explosion due to the heat produced when water comes in contact with hot H2SO4 acid. Why hot H2SO4 acid? Because right before collection, if you remember, you have a drying agent, that is H2SO4. So concentrated H2SO4 is the drying agent, and if water reaches there, of course there is a chance of explosion. Now next is, what precaution do we use? So an empty flask is put between the generative flask and the water trough. So what is happening? Before this funnel, like if you see right here, before this we keep a empty flask. So the gas after drying will come in this, and after that it will come in the in the one that you are dissolving it in water. So you introduce an empty flask. They can ask you this question: what kind of precaution would you put in to avoid back suction or explosion? So you will introduce an empty flask in between. Now let's look at a couple of points. A constant boiling mixture or azeotrope is a solution. So what happens is that you have water, you keep dissolving HCl gas. Now there comes a point where HCl gas does not dissolve anymore, At this point, if you are even heating up water, so it becomes constant. No more HCl gas is dissolved in it. Why does that happen? That happens because at a particular temperature, the amount of HCl gas that is because it's a volatile one. So the amount of HCl gas that vaporizes and the amount that dissolves in it is exactly the same. So the entire mixture stays at a constant saturation point where you cannot measure up any more HCl gas being dissolved in it. Such a point is known as a constant boiling mixture. So a constant boiling mixture or azeotrope is a solution which boils without any change in its composition. HCl acid forms constant boiling mixture at 110 degrees Celsius. At this particular temperature, the acid that you have is 22.7% by weight and water that you have is 77.8% by weight. Now next is liquefied HCl and dry HCl does not conduct electricity due to the absence of ions. So when we started this portion, I told you that HCl gas, on mixing it with water, you get the ions, it get ionizes. But that is not true for liquefied HCl or dry HCl. Because liquefied HCl means that you had HCl gas, dry, you pressurize, you put pressure on it and that gas turned into liquefied HCl. So there is no water in it, so no ions are present. Similarly for dry HCl, no moisture, no water, so no ions. Both of them have absence of ion, therefore does not conduct electricity and it will not show any change on the litmus paper also. If you are mentioning moist litmus paper, then yes, it will show a change. But if the question says the change it will show on a litmus paper, unless and until it is mentioned moist, there won't be any change on it. Next is HCl gas is soluble in toluene. This is an organic compound. But in this case, it neither changes blue litmus to red nor conduct electricity. This means that HCl gas is soluble or does dissolve in toluene, but it does not ionize in it. Since there are no free ions present, therefore no conductivity of electricity, no conduction of electricity, and no change on a regular litmus paper. But if they mention litmus solution or they mention moist litmus paper, yes, it has a chance. Of course, it would show change because there is moisture present. Let's move on to the next one, that is tests of HCl. So the first is irritating smell. The second one we already discussed, that is glass rod dipped in ammonia brought near HCl will show thick white fumes of ammonium chloride and the equation is NH3 plus HCl plus NH4Cl. Okay, and these other two will come back on it. So let's cover up the rest of the portion. Now let's come on the chemical properties. So when you talk about HCl acid or hydrochloric acid, when it reacts with metals, it will give you a metallic chloride plus hydrogen gas. So calcium, magnesium or zinc reacting with HCl will give us what? Calcium chloride or magnesium chloride or zinc chloride, and along with that it will give you hydrogen gas. The second one is action on oxides or hydroxides. So if you have oxides or hydroxides, it will convert it into a chloride, metallic chloride, and it will give you water along with that. So MgO, ZnO, FeO will give you MgCl2 plus water. So a corresponding metallic chloride plus water. Now let's come on the hydroxides. Same thing will happen with the hydroxides. You will get a metallic chloride, along with that you will get water. Now next is with salt of weaker acids. Okay, so what would happen in this case is that it will give you a salt, that is a metallic chloride, plus water, and since you have carbonates and bicarbonates here, you will get carbon dioxide gas. Everything else stays the same, that is you get a metallic chloride and water, but since it's a carbonate or a bicarbonate, you end up getting carbon dioxide gas. So always remember, majority of the cases when you have a carbonate reacting with an acid, you end up getting carbon dioxide unless there is an exceptional case. So if you are not sure of the answer, you have a carbonate reacting with the metal, make sure that you are giving out carbon dioxide and water and whatever salt you can make. So let's look at that. Na2CO3 plus HCl gives NaCl plus H2O plus CO2. And similarly, you have for bicarbonates. Let's move to other chemical properties. Here you have sulfides and hydrogen sulfides. So when you have sulfides, you get SO2. Okay. Now with metallic sulfides, IDES, in that case you end up getting a salt plus H2S gas, rotten egg smelling gas. If you are not sure how to identify these gases, you can check out the anion detection video that is there on the channel, in which I have mentioned all the details about different gases and how to identify them. Let's move to the next chemical properties, that is with thiosulfates. This is an important one. This is an exceptional cases. So this is important. Na2S2O3 plus 2HCl. In this case, you get NaCl, water and SO2. But you also get sulfur as a precipitate. This is a yellow colored precipitate that comes out when HCl reacts with thiosulfates. So this is an important equation to remember. Now, as an oxidizing nature, you have just one equation in the syllabus, that is MnO2 plus HCl will give you MnCl2 plus water plus chlorine gas. Okay. Now, let's come on the next chemical property, that is the precipitation reaction. So, HCl gas does not react with nitrates. So, generally it does not react with nitrates except lead and mercury. Okay. So, lead, mercury and silver nitrates, it does react. When we talk about lead nitrate, you get PbCl2 plus HNO3. This is a white precipitate. Okay. And the PPT for lead dissolves on heating. So, if you keep heating it, the precipitate that you got for lead will eventually dissolve. Now, when we talk about mercury, you get Hg2Cl2 plus HNO3. Now, let's come on silver. So, silver nitrate plus HCl, you get AgCl plus HNO3. AgCl is a curdy white PPT. This PPT is insoluble in HNO3, but it is soluble in ammonium hydroxide. So, students, make sure that this is extremely important for you. So, you pay more attention here, that AgCl is a curdy white PPT which is insoluble in HNO3 but soluble in ammonium hydroxide. Okay. So, now what happens is that this AgCl is reacted with ammonium hydroxide. So, if you can see, I have an arrow mark here. So, AgCl plus ammonium hydroxide will give you a salt like this. Okay. So, when you have this salt plus water and you combine it with nitric acid, you get white PPT of AgCl. Okay, makes sense? Now, when exposed to light, silver chloride blackens since it decomposes into chlorine and metallic silver, which is liberated as a fine black powder. Okay, so make sure that you're paying attention in this. Silver nitrate, when it reacts with HCl, gives you AgCl, which is the curdy white PPT. This curdy white PPT, when reacts with ammonium hydroxide, gives you silver diamine chloride plus water. This entire compound, when reacts with nitric acid, will give you a white PPT of AgCl. And when you expose this to sunlight, you get silver chloride, it blackens since it decomposes into chlorine and metallic silver, which is liberated as a fine black powder. Okay, let's move on to the last portion now, that was the tests. So AgNO3, which I just mentioned, this is the test right here. AgNO3 plus HCl gives AgCl plus HNO3. The AgCl is insoluble in HNO3, but it dissolves in ammonium hydroxide. So this particular test is valid for HCl gas also and acid also. Now next one is your oxidizing equation that we just did. So since you are getting chlorine, this identification will, you can just mention that a greenish yellow gas appears which turns moist starch iodide paper blue black, which means that the chlorine gas is present, and hence you can identify that HCl gas or HCl acid was present. So this is it on this. So thank you so much, students. This was it for today's session, and we were successfully able to go through the entire portion of HCl. So I hope this was helpful for you. Make sure that you leave a message in the comment section, and I will definitely revert back for any queries or doubts or requests. Thank you so much. We'll catch up in the next session, that is ammonia.